So moving on to chapter 4, correlation, we're starting with section 4.1, and this should be very familiar to this idea of a strong negative correlation, the gradient is negative, but all the points are very close together. A weak negative correlation, the gradient is of the line of best fit is negative, but the points are a bit further apart. No correlation, everything all over the place. Weak positive correlation, strong positive correlation. So hopefully we're familiar with that idea. A couple of things to remind you of. Correlation, as far as the word is used in everyday speech, might just mean a link. So I might say there is a correlation between one thing and another. I just mean there's a link between one thing and another. In maths, if we're saying correlation, in this chapter particularly, we mean it is a linear relationship between two things. So for example, there is an exact relationship between the x variable and the y variable on this graph. But I wouldn't call it a strong or a perfect positive correlation because it's not a linear relationship, it's a curved relationship, okay? In the same way, this is a helpful diagram. These points, clearly something's going on here. Clearly, those points, if they're forming a perfect circle, the x, whatever we're plotting on the x-axis, whatever we're plotting on the y-axis, there must be some sort of link if we're getting exactly this, but it makes a zero because that is a zero correlation. So a little sort of mnemonic to remember that with. The zero correlation doesn't mean there's zero link, it means there's zero correlation. It's not a linear relationship here. In practice, of course, if there is zero correlation, if you're going to get a graph that looks like this, if you've got a graph that looks like this, there probably is no link between x and y, okay? It's just a pedantic point to make about what we mean by correlation. It has to be linear if we're going to use that word for this topic at least. Now, when we have a scatter graph and we've got a correlation, we can draw ourselves a line of best fit. Now, a line of best fit so far, before this module, is just been put your ruler on the page, try and get half the points either side of it and sort of draw a nice line through the middle of it. Now, what we'll see at the next book, on the A2 book, is that there is a way of calculating from the data. You can calculate what the line of best fit should be. And when we do the calculations, we get what we call a regression line. Now, in this module, all that we need to know is that we understand that there is a thing called a regression line, which is the same thing as a line of best fit, as give or take, it's exactly the same thing as a line of best fit. The reason I say give or take is because there are other ways of finding lines of best fit. This is the one that we're going to use for, and it's called the regression line. But they're going to give us the equation of the line of best fit here, okay? So we've got an exact line of best fit. We're all working from the same one. We're not just guessing where it is. They're very fond of asking you about what the coefficient b, what the coefficient of x means. So, for example, on this one here, remember the coefficient of the w. So this is g and w instead of x and y. But the coefficient of the w is the gradient of the line, isn't it? So the gradient of the line means that if I increase 1 unit on the x-axis, that's how many units I increase on the y-axis. So in this case, if the daily mean wind speed w increases by 1 unit, which is 1 knot, then the daily maximum gust can be expected to increase by 1.82 knots, okay? So they're very keen on that question, and I'm sure you'll see that several times if you do enough practice before the exam. A couple of things about the regression lines. This regression line is called the regression line of y on x, okay? So it should always be of the thing on the y-axis on the thing on the x-axis. That's just the name that we give to it. Now, we're used to using lines of best fit to predict values. So in this case, you might say something like, if the daily mean wind speed is 15, what would you expect the daily maximum gust to be? So the way you would do that is draw the line of best fit as neatly and accurately on the graph as you can, and using it in the usual way, go up to the line and across the axis. Now, the important thing to notice is if you've got the regression line of g on w, if you've got if you want to use that to predict a value of g, you can do that. Pick your value of w, go up to the line and across. If you want to do it the other way around, you shouldn't use this regression line. You shouldn't start with a gust and go backwards because of the way the regression line is found. that's sort of not an allowable operation. And of course, that's the sort of question they're going to be keen on asking you in the exam. Why, if I give you a maximum gust of 40, why can you not predict the daily mean wind speed using your regression line? And the answer is just straightforwardly because it's a regression line of G on W, not a regression line of W on G. A couple of other things to mention. We have the dependent and independent variables, which, there we go, here's the definition. So we have dependent and independent variables. So the dependent variable is the, sorry, I'm trying to find, somewhere in here there is a definition. It doesn't really matter, does it? The independent variable is the one that goes on the x-axis. The dependent variable is the one that goes on the y-axis. The independent variable is the one that we get to choose, okay? And the last thing to point out is this little pink box here, interpolation and extrapolation. So let's take this line of best fit as an example. If I have, so this is gestation period and head circumference. So if I have a gestation period between the lowest piece of data and the highest piece of data, then I can use that to predict a head circumference. So for example, 36, I could predict the head circumference if the gestation period is 36 weeks. Now, if I'm using data outside, so let's say I have a gestation period of 42 weeks, then can I use this regression line to predict the head circumference? Well, the quick answer is no, you shouldn't. If you have a gestation period in the range of values that you've got, you can use the line of best fit, and that's called interpolation. Outside of that range of values, it's called extrapolation. The quick answer is extrapolation shouldn't be done. You shouldn't do it because you don't have information. You don't know if this trend carries on outside of this data. In practice, if you're close to the data you've got, you might want to use extrapolation, but you should be very careful about extrapolating if the value that you have got is a long way away from the data that you've got. Okay, so if you're trying to predict what happens with a gestation period of 80 weeks, this graph would definitely not be any good for you. Now, in some situations, we have to use extrapolation, and the example I'm fond of using is weather forecasting. We can look at all the data up to today, but if I want to make any prediction about the weather tomorrow, I've got to extrapolate from the data today. And not just weather forecasting, but any other sort of forecasting. We're often interested in what we think is going to happen in the future. That has to be extrapolation because we can't possibly have any data from next week and then predict what's going to happen tomorrow based on next week's data. It's just not possible. So the straightforward exam questions on this say, why shouldn't we use this to predict from this number? And you'd say, well, because it's extrapolation. If they're getting a little bit cleverer, then they're going to ask you to make some sort of judgment call and say, well, would this be sensible? And you can say, well, it's extrapolation, so it's not great. But on the other hand, we're predicting the future, so there's no way of getting out of it. Or on the other hand, the value isn't too far outside of the set of data that we've got, so it's not too bad. What I'd recommend there is looking at the mark schemes on the sample assessment material or on the past papers and seeing the sort of things that get marks and the sort of things that don't get marks to make sure that you're used to that come the exam. Now, obviously, it's not all about exams. In real life, you'd have to make a judgment call. So just make sure you've got a good idea of the problems involved there and where you think your judgment should fall. And like most things in statistics, if you get trained more in statistics, you wouldn't make a judgment call. You would use statistical methods to decide whether or not it's a good thing to do.